This is Cam Jackson of Silicon Bright Technologies. Today I'm demonstrating the SBT3000, which is a small 8-pin SOIC. What it does is it protects against AC, line over voltage conditions, and I'm going to show that now. This is the SBT3000 on a little demonstration circuit board. I'll explain briefly my setup. So first of all, I have a variac which takes the input power. I can control the voltage. That goes into a step-up transformer, and the reason for the step-up transformer is with the normal line voltage here, I can't get high enough voltage to trip the SBT3000 to create artificially an overvoltage condition. So from the step-up transformer, I've got two current sense resistors. Those go into two current sense channels on the oscilloscope. And I have two completely separate channels. One of them comes through the SBT3000 into a light bulb load. The second channel comes through a fuse into two voltage monitors, one for the SBT3000 and the other one is for the Varistors, and then that goes into the other two channels on the oscilloscope. On the oscilloscope I have the ACV in green, the ACI in, the current in yellow. I have the SBT3000 output voltage in brown, and I have the SBT3000 output voltage, current in blue. So I'm going to increase the voltage here, and I'm not, at this point, all I'm doing is demonstrating the functionality of the SBT3000. I'm not comparing it to Varistors at this time. The Varistors are actually disconnected. So to do that, I'm going to increase the voltage, input voltage, and as you can see on this meter, this fluke meter, the voltage is increasing. You see on the green trace, it is increasing. I'm at 57 volts. The SBT3000, you can see the input voltage in the red, and you can see the output voltage in green. I'm just going to decrease that voltage a little bit below 56 volts, and then I'm going to turn back on the voltage. You can see the input voltage, and then after a brief amount of time, let's see, I'm going to increase to 60 volts here. I'm at 60, and the output voltage turns on. So the first feature that the SBT3000 provides is under voltage protection. You can see that both lamps are just barely turned on, and I'm going to increase the input voltage into the SBT3000. I'm at 80 volts, 90 volts, 100 volts, 113, 17, 120, and the SBT3000 remains turned on until you get to about 143 volts. You can see that on the meter there. And at about 143 volts, oops, a little bit more, the SBT3000 actually turns off. The reason why it does that is to protect the load from overvoltage conditions. So the input voltage is at more or less 150 volts AC at this point, and the output load has turned off. The SBT3000 has done its job and protected. Now I'm going to compare that to the operation of the Varistor in the next part of this video. The reason why this video is being done with Varistors on the output of the fixture is that a very common protection method for anything, this is a power supply, but televisions, anything, is to have an input fuse. This is the input fuse in this case, and that input fuse protects the Varistor. The Varistor protects the rest of the circuitry. So what happens then is if the input goes over voltage for longer than maybe half a second or 1 second, the fuse blows and it protects the rest from going up in fire. But what happens is the fuse at this point has gone. It's not a user replaceable fuse, so the whole assembly has to be replaced. So the next part of this video actually explains the input voltage goes through two channels, one through a fuse into these two Varistors, which are in series. The other channel goes through the SBT3000. Both channels go individually into a load. On the underside of the varistors is mounted a thermocouple. There is two thermocouples here, one to measure the varistor temperature and one to measure the ambient temperature. The difference between those two temperatures is just simply the calibration of the two thermistors. So the other thermistor is glued on the underside of the varistor. So I'm going to watch this varistor as it starts to clamp. You're going to hopefully see the current come up, and at some point the fuse may blow. We'll see what happens here. So I'm bringing up the voltage right now. We can see the input voltage coming up on the SPT3000 LEDs, and on the input we're at 32 volts. And it looks like we've got some current happening on the input, which is interesting. We're at 200 milliamps per division, and it looks like there's a little bit less than 100 milliamps there that is flowing. I'm increasing the voltage more, 40 volts. $50 volts. $60 volts. The SPT3000 has turned on. 60 volts. You're starting to see the lamps illuminate. 70 volts. 80 volts. 90 volts. So look at the temperature on the varistor. The temperature in the varistors is coming up now. And look, we're at 145 volts. Look at the temperature on the varistors. It's now 66 degrees C on the varistors. The SPT3000 has protected. It's turned off. But look, the temperature continues to rise. We're at 85 C on the varistors, 93 C, 100 C. Pretty soon those are going to go up in smoke. 110 C, 114 C. Look at the current. Look at the current waveform. It's just, the current is crazy. Look at the smoke coming off the varistors there. Can you see the smoke coming off the varistors? And there goes. What happened there was there's a 1 amp fuse in series with the varistors. The 1 amp fuse blew. There's a neon lamp across the fuse, so the neon has illuminated to indicate the fuse has blown. And the varistors, look, they're at 161 degrees C. They're getting cooler now. They're cooling down. But they were hot enough that smoke was coming out. It was protected by this 1 amp fuse. So in a normal customer application, the fuse would blow, would be non-replaceable, and this channel would stay turned off. Now I'm going to decrease the voltage down again. Now I still have 140, 150 volts on here because the SPT3000 has turned off, so I can't see the input voltage. But look, as soon as I decrease the input voltage down again, the SPT3000 channel turns on. The varistor channel is done. It's finished until the fuse gets replaced. So the SPT3000, look, it's turned back on again. Imagine this is your TV. Your TV would be turned off until basically you buy a new TV. And with the SPT3000, your TV turns back on again. I'm going to raise the voltage again on the SPT3000. and we see it turns off and protects again. We turn the voltage back within normal input range. It turns back on again. We increase it. It turns off again. And the advantage to the SBT3000 is it can turn on and off as many times as required, where the fuse will blow once. The varistors now, even if I change that fuse, those varistors may be damaged. This is Cam Jackson from Silicon Bright Technologies with an explanation of the SBT3000 protection IC. Thank you.